Logarithms. It's really only the inverse of an exponential function. This discussion is a basic tutorial on logarithms and how to convert them from exponential function or exponential form, and how to use them a little bit. Then following this, you would be wise to watch parts 1 and 2 of the log rules to get a better understanding of logarithms. But let's begin. Let's start with an exponential function, such as, let's see, 3 squared is equal to 9. Okay, we know that to be true. 3 times 3 is 9. If we were to write that into log form, we would have log, this would be 3 here, 9 is equal to 2. That would be the proper format to convert this to a log. And actually, you are solving for, not solving, I'm sorry, you're actually showing the inverse of an exponential function. Let me explain. Perhaps this would help some. Notice this. Y is equal to EX. Y is equal to ln x. Now, recognize this right here is basically the same as saying log x is equal to y. So if we were to take, now notice the graph here. This graph here is a graph of this right here. Base raised to an exponent is equal to y. Now, notice that this, when you convert it into log, becomes just the inverse. And notice what the graph looks like. So here's where they're kind of like mirror images of one another. But you can use logarithms to solve exponential function and vice versa. Now let's go back to our original discussion and discuss this a little bit. First of all, the format for this is ax is equal to y, and you convert it this way. Log a y is equal to x. Now, notice what happens. The a becomes our base in the log. The x becomes our equal to, and our y then is right here is the number for the log. And when I rewrote it here, notice where I put the 3. The 3 here, it goes here. The 2 was what it was equal to, and the 9 is right there. Alright, let's have you try one. You convert that one. Pause the recorder now. Okay, is that what you received? What you got? Very good. All right. Now you can use this knowledge by going to go backwards as well. Let's say that you had a log, log 12, 144 is equal to 2. How would you rewrite that in exponential function? How would you write the inverse of that? Take a minute, pause the recording. Well, you should have rewritten it this way. 12 squared is equal to 144. Okay. Now, with this knowledge, you should be able then to solve a problem that looks like this. Let me Make a little room here. Let's say we had a problem like this. Let's say we had something like this. Log 2x is equal to 3. What is the value for x? Let me give you a hint. If you will rewrite this in exponential form, the answer may become apparent. Well, 2 cubed is 8. 2 times 2 times 2. So using this conversion, or this inverse property, using exponent function and then going back to log or vice versa, can help us solve some of these problems. Now, let's take a problem like this right here. What if we had log 2 parentheses m minus 2 equals a negative 2? Okay. How would we try to solve for m? Well, let's convert this back to an exponential function. You would have 2 negative 2 is equal to m minus 2. Well, 2 to the negative 2 we know to be 1 over 4. And equals to m minus 2. Well, let's subtract 2 from both sides. Minus 2 on both sides. We would need to see that would equal, m then is equal to, and let's rewrite this right here as negative 2. We need to have a common denominator, so let's make that 4. Put 8 on top, and that's going to be a negative 8, because that's actually 8 over 4 makes a 2. And this has a positive 1 over 4. So that becomes 7 over 4. Negative 8, positive 1, add the numerators, get the same denominators. So m is equal to a negative 7 over 4. And that's how we use this conversion method to solve. Alright, let's try something different. A little different problem or approach to it. What if you had a problem like this? Log 3 a plus 1 is equal to 5. Now notice, this one here is different than this here. Notice the m minus 2 is in parentheses here, and it's not here. So this is actually, that's not written really well. Let me rewrite that real quick. This is actually log 3a plus 1 is equal to 5. Okay. In order to solve this for a, we can use the same techniques we've been using. However, we need to first move this positive 1 to the other side of the equal sign. We do that by adding the opposite. So we get log 3a is equal to 4. Now, let's convert it to an exponential function. So you have a base of 3. 4 here is equal to a. 3 to the 4th power is the same as 81. So then a must be equal to 81. Now, a little more challenging problem could be something like this. 3 parentheses log 3. Let's see. Let's change this log to 2. Boy. Log 2 and make this x minus 6 equals, oh, think, 27, negative 27. Okay. Now, again, this is log 2x. We can't convert this as it is to an exponential function. However, what we can do is start moving things over. So let's move this negative 6 over first, plus 6 to both sides. Always do the adding, subtracting part of it first before you multiply, divide. So when you're solving for a variable, that cancels out. There you get a negative 21. Now we divide by 3 on both sides. So we end up with log 2x is equal to a negative 7. Now let's write it as an exponential function. 2 raised to the negative 7 power equals x. Alright, 2 to the negative 7 is 1 over 128 equals x. So there is my answer for x. Started out here, subtracted or moved the negative 6 over first, then we divided by 3, and we was able, after that, once we had the log all by itself on one side, was able to rewrite it in exponential form to be able to solve. Okay, that concludes our discussion on the inverse of exponents, which is logarithms, and just some basic solving skills.